Okay, hello and welcome everybody. Happy New Year. This is our new homework module for section 5.1 through 5.3. Happy to be back with everybody here. So let's go ahead and get this thing started. Our first section is solving systems of equations by graphing. And so let's go ahead and zoom in on this. Zoom. And so what this is asking us to do is it wants us to substitute the given point. So substitute means to plug in, right? Plug in the given point into both equations to determine which ordered pair satisfies the system of linear equations. Graph both equations and label the point of intersections to verify the solution. So this is going to be a multi-step problem. The first thing that we're going to do is we're going to look at our A here. And A is the point 0, -2. And we're going to plug that into both y equals 3x minus 2, because that's this equation here, and y equals x. And so that's that equation here. So I'm going to go ahead and do that. So my x is 0, my y is -2. So I plug -2 in for my y and 0 in for my x. So I get -2 equals 3 times 0 minus 2. 3 times 0 is 0, so -2 equals 0 minus 2. So -2 equals -2. So yes, it does work for that first equation. Now we have to see if it works for the second equation. So I plug 0 in for my x, -2 in for my y. Does -2 equal 0? No. So I know that that is not a solution. And then I do it again. This time I'll do it for the point 2, 2. All right, I'll scoot this up a little bit. So then I have 2 equals 3 times 2 minus 2. So 2 equals 6 minus 2. 2 equals 4. That's not true. So I know this isn't true, so I don't have to do it anymore. Meh. Meh. All right, so now I do it one more time, this time for the point 1, 1, because B is wrong, C is right. So I do the point 1, 1, 1, comma 1. Okay, and I do it for this equation again. So I do it 1 equals 3 times 1 minus 2. So 1 equals 3 minus 2. 1 equals 1. Cha-ching. Okay, it works for that first equation, so let me try it with the second equation. So 1 equals 1. Hey, whoops, I wrote y because I was so excited. Yes, 1 equals 1. So I know that 1 equals 1, or 1, 1 is going to be my solution to this system. Because it's true for both this equation and it's true for this equation. If it's true for both, that means that must be the point of intersection. It then wants us to graph both equations and label the point of intersection. So I'll start with this one, y equals 3x minus 2. Well, that's just simply y equals mx plus b form. My b is -2, so that means I cross the y-intercept at -2. That's what the b is, the y-intercept. And then my m, which is my slope, is 3. That means I go up 3, 1, 2, 3, over 1, over 1, up 3 over 1, etc., etc. 1, 2, 3 over 1, like that. Okay, and so that will create a line that looks a little something like this. Okay, so that's my first equation. And then my second equation is y equals x. So my b, there's nothing here. There's like we imagine like an invisible plus 0. So that means it crosses at 0. And then there's no number in front of the x, but we all know that that's actually a 1. There's an invisible 1 there, so that means I go up 1 over 1, 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 up 1 over 1 forever and ever, and then backwards the same way, creating a line that looks like this. Boom. Okay. And so there's my line, and then here's my point of intersection, and it says it wants us to label the point of intersection, so this is point C, which is known as 1, 1, all right? And so that's what we would do to do these, and then we do it again here and here and here. All right. Next, let's turn the page, turn around. Determine possible solutions to the inequalities. All right, so it says possible solutions. That's telling us that there's, whoops, I need to scoot this down, don't I? Determine possible solutions to the inequalities. It tells us possible solutions to inequalities. And remember, inequalities are going to be our less than, greater than, less than or equal to, greater than or equal to signs. And when we're talking about values that are less than, greater than, less than or equal to, greater than or equal to, we're talking about multiple values, right? When I say x is greater than 3, there's a lot of numbers that are greater than 3, 4, 5, 6, 7, 8. I could go on literally forever. It's an infinite number. And so there's multiple solutions. And when it says possible solutions, it means there's going to be multiple possibilities. It's not just going to be one solid number. So let's go ahead and look at this. A theater wants to take in at least $2,000 for the matinee. So when it says at least $2,000 for a matinee, that means they want more than or equal to, so some number that's greater than or equal to 2,000, okay? They want some number that is bigger than or at the very least 2,000, or equal to or more, okay? Children's tickets cost $5 each, and adult tickets cost $10 each, okay? So we've got $5 per child, and we've got $10 per adult, okay? The theater can seat up to 350 people. Find 5 combinations of children and adult tickets that will make the 2,000 goal. So I mean, we can guess and check to figure this out, or we can be a little bit more strategic about it, okay? So like if we had 350 people can fill it, okay? What if there were 350 adults? So if I had 350 adults that each paid $10 a ticket, I would have $3,500, right? That is greater than or equal to 2,000. So I would know that one combination would be 350 adults and 0 children, okay? Likewise, if I had maybe 349 adults and 1 child, right? What would that be? Well, that would be 349 times 10 plus 1 child at $5. So that would be, $3,490 plus $5, which would still be, $3,495, which would still be greater than 2,000. So we could do that, and then you could kind of see like we can keep doing this. 3,048 and 2. Now, that's not terribly interesting. An interesting number would be trying to figure out how many do we, what's the most number of children we can fit in here? Like, what happens if we put 350 children in here, which is a terrible idea. Like, can you imagine 350 children without a single adult nearby? Oh my gosh, it'd be like CMC without the teachers. So if we do 350 times 5, we end up with 1,750. So we couldn't even do this anyway. This doesn't meet our goal. If we just filled it with children for $5 a piece, we wouldn't make the amount of money that we wanted. So the interesting thing comes in trying to figure out where that is. But that's not exactly what it's asking us. It just wants us to find 5 combinations. And you can see if we just continue this pattern, we could easily figure out 5 combinations, 346 and 4. See? Those are 5 combinations. 1, 2, 3, 4, 5. All right, next up. Finally, that has happened to me. All right. Graphing linear equations to determine if a given value is a solution. It wants us to graph each equation below to determine if the point 3, 5 is a solution. And then it wants us to find 2 points other than 3, 5 that are solutions, and then show them on the graph, okay? So the first step is just to graph this. This is, we know, again, y equals mx plus b. In this case, my b is -1, my m is 2. So I know my b is my y-intercept. This is my y-axis. That means I cross at -1. My m is 2. That means I go up 2 over 1, and then I go up 2 over 1, and up 2 over 1 for infinity. But I'll stop here because I'm at the edge of the graph. Okay, so those are the things that make up my line. And I just need to draw it in. Something like that. Put little arrowheads on it to show that it goes on forever. And there we are. All right, and so that's what I have. And so now I'm interested in the point 3, 5. Is 3, 5 going to be a point on my line? So I go over to where x is 3, 1, 2, 3, and I go up to where y is 5, 1, 2, 3, 4, y is 5, and I see right here, is that a point? You betcha. 3, 5 is a point. So there's 3, 5, it's a point. But it also wants me to find 2 points other than 3, 5 that are solutions. And so I was very meticulous about making these and making sure that I had these points here. So let's just go ahead and figure out what these points are. When I look at this point here, boop-a-doop, just pick one. I see that my x is -1, my y is -1, 2, 3. Boom, easy. There's one. I just got to do one more. How about this one? How about this one right here? Cool. I see that my x is 1, 2, 3, 4, 5, and my y is 1, 2, 3, 4, 5, 6, 7, 8, 9, 5, 9. 5 and 9. And there we go. I have found 2 other points, and I've shown them on the graph. And so I used an orange pen. You don't have to do that. You can just make a bigger dot or whatever works for you. But there we are. That's our first homework section of the new year. Good luck. Do good work, and I will see you tomorrow.